हेलो दोस्तों, कैसे हो? मेरे इस YouTube चैनल में आपका स्वागत है। तो चलिए शुरू करते हैं। And then we had seen this design of joint subject to eccentric loading, this type of cases, and how to solve this type of sum. First we have to find primary shear stress, then we have to find secondary shear stress, and then we have to add primary and secondary shear stress, and then finally we have to find the what size of the weld. Okay, how do we find primary shear stress? So there are only three steps, four steps rather. First step is to find primary shear stress, second step is to find secondary shear stress, third step is to find total shear stress, and fourth stress is to find the size of the weld. Now we'll go in detail in every step. First step is to find primary shear stress. Primary shear stress can be found by the formula load upon area. Load is P, area is 2 into T into L. This 2 depends if there are two welds. If it is single weld, it will not be 2, it will be just T into L. Substitute T is equal to 0.707 S and you get the value of sigma 1. Then what is the formula for sigma 2? We call it as Mr. J, MRJ. So Mr. J means M is moment, so moment is force into distance, force is P, distance is E into R2. So this will give us the value of tau 2. And then how can we add tau 1 and tau 2? Either we can add it algebraically by resolving, or we can add it by using law of parallelogram of forces. And finally tau is the value which is to be used to find the value of what the size of the weld. And then in the process we have to draw this sketch like this. This is the sketch where uh, there is something called as R2. R2 is the distance of the farthest end from the CG of the weld system. The first step is to find CG of the weld system, and then from that we can find the other values. So we'll see today how to solve a sum on this by practically implementing this thing. We have this plate, and this plate is to be welded to this plate. Okay, so these are the two plates, and where the welding is to be applied, the welding is to be applied here. Or rather, I will do it here by this. It is to be welded here and here. Okay, and the forces applied will be like this. There is one force here. Then what we have to do? We have to find the CG of this weld system, and obviously this will be horizontal, and this width of the plate will be given to us. And what we have to find? We have to find size of the weld. So you can see there are two plates and the loading is eccentric loading. Is 15 kilonewton. Load is 15 kilonewton. This distance is 80 mm and its CG is here. This is G, and from CG this distance is eccentric distance. I am taking it as 125. So a bracket carrying a load of 15 kilonewtons. You can see a bracket. It is carrying a load of 15 kilonewton, and it is to be welded to another plate as shown here. This is one plate. This is one plate. Okay, and this is another plate. This one is another plate. So these are the two plates, and these two plates are to be welded. Where is the weld? The weld is here. The weld is applied here. This green color. This is the weld. Okay. So which type of weld is it? It is double parallel fillet weld. Double parallel fillet weld. Correct?
Yes, sir.
Yes, double parallel fillet weld. And where is the CG of the weld system? Now since this distance is 50, this distance is 50, the CG will lie at what distance? 25. So do we need to find the center of gravity? No, we do not have to find center of gravity in this case, because it is a case where CG is easily understood. You can identify CG just by looking at the sketch. What is the distance of eccentricity? E 125. Okay, 125. And if the allowable stress in the weld is given as 80 MPa, allowable which stress? Shear stress. So what is given? tau max permissible is equal to 80 Newton per mm square. What is the value of P? 15 into 10 raised to 3 Newton. What is the value of E? 125 mm. Okay, this is what is given to us. Now, as I explained to you, what you have to find? Size of the weld. Size of the weld is S. To find S is equal to size of weld. And this thing is given. This thing is given. Okay, what are the steps? Step 1. Step 1. Step 1 to find primary shear stress. Okay. Step 2 to find secondary shear stress. Shear stress. Then step 3 to find total shear stress. And step 4 to find size of weld. See how simple this sum is. How simple it is. Just you have to find 1, 2, 3, 4, 4 things. Now how do you find this? This is tau 1 is equal to P by A. Correct?
Yes, sir.
This is tau 2 is equal to Mr. J, MR by J. We'll elaborate this. Then to find total shear stress, that is tau max is equal to tau 1 plus tau 2. Now understand that I am writing tau 1 plus tau 2, but it is not exactly tau 1 plus tau 2. I have already explained this yesterday, how to add. I am writing it just for the sake of understanding. And finally, what will we do? We'll compare this tau max with tau permissible. Tau permissible value is known to us, that is 80, and we'll compare it with tau max, and finally we'll get the value of S. That's it. It's that simple. Okay, then how do you find tau 1? P by A. P is what? P is P. That is
15 kilonewton.
Yes, 15 kilonewton. So this is 15 into 10 raised to 3. What is A? A is the area. Area is what? Thickness into length. So T into L. And how many welds are there? 2 welds.
1.414 into S into.
Yes, just a minute. And in the denominator, what will we do? 2 into T can be written as 0.707 S into L is what? L is given as how much? 50. L is given as 50. Where is L? Length of weld. You can see this is length of weld L. यहाँ से वेल्ड यहाँ तक चालू हुआ है ना. इसका ट्रायंगल कहाँ से दिखेगा? You have to view from here so that you can see the triangle. You can see the triangle from here, from this side. So into 50. So what will you get? 212.16.
212.16 upon S.
Okay, so now the second step to find tau 2. Okay, now I am writing it in one stretch. You have to write it step by step, one below the other. ऐसा नहीं लिखना है तुमको. Now second is tau 2. So that I will have to do here now. Tau 2. That is step 2. To find secondary shear stress. Now we have this formula tau 2 is equal to mrj. So this is P into E into R upon J. Which R we will take?
Sir, R2.
Yes, we will take R2. Now what is this R2? R2 is the distance of
to the farthest point.
correct distance of the CG. You can see here CG, that is G, from the farthest point, that is this. Which distance? This distance. This is R2. This is R2. So what all things we need to find sigma 2? We need P. P is known to us. E is known to us. J is to be found. Okay, J is what? Polar moment of inertia. And then R2 is to be found. So we'll first find R2 and then we'll find J. Now understand, for R2, I will draw that sketch here. And here we have this point G. And we are saying that this distance is known to us. This distance is R2. What is this distance from here to here? This is 40.
Yes,
This
sir.
is okay. This is right angle triangle. Then what is this distance from here to here?
Sir, 25.
This is 25. So what will be the value of R2? किसी को ये समझा नहीं तो पूछो डिस्टेंस 25 कैसे आया है और ये
Root of
डिस्टेंस 40.
40 square plus 25 square.
हाँ, how much is it? Okay, 47.19. Okay, that is R2. So I can write here R2 is equal to 47.19, no?
Sir, 0.17.
17, 42, 1.17. And this will be in mm. Now we got the value of R2.
Sir, it is 47.17.
Okay, 47.17. Okay. Now next what we have to find? We have to find J. So what will we do now? Instead of writing this as step 2, see, instead of writing this as step 2, what will we do? We will break this into to find value of R2. Say this is step 2. Then step 3, to find polar moment of inertia. Polar moment of inertia. Now to find this polar moment of inertia, what is this? We have one thing here. This distance is 50. Now this is the important step in this, to find polar moment of inertia. The polar moment of inertia is what? J. What is J? Ixx plus Iyy. Any doubt to anyone in this? J is polar moment of inertia. And how do we find this? This is Ixx plus Iyy. This is which theorem? Can anyone tell me?
Sir, perpendicular axis theorem.
Perpendicular axis theorem. So for to in order to find J, we need to first find Ixx and then Iyy, and then we can find the value of J. Now how do we find Ixx? So here Ixx. What is Ixx? Ixx is the moment of inertia of this weld. Okay. Now where we have to find this moment of inertia? About, do we have to find it about its own CG or about the CG of the weld system? This is the CG of this weld and this is the CG of this weld. Okay. So what I will do is I will say this is x1, xx1, and this is xx2, xx2. Now moment of inertia Ixx is what? How do we find it?
Sir, the side parallel to into the perpendicular side cube upon 12.
Okay, now I am asking Ixx. Ixx means what we have to find? We have to find about this axis. This is G. So we have to find, in fact, if I say this is xx. So we have to find moment of inertia of both the weld about what? About the x axis, that will give us ixx. ये समझ लो, बहुत इंपॉर्टेंट है. अभी तक भी जितना मैंने बताया, आई एम रिपीटिंग इट, and if you have any doubt you can ask me. See, we have to find polar moment of inertia. What is that polar moment of inertia? J. Polar moment of inertia क्या होता है? It is the moment of inertia about the axis perpendicular to the other two perpendicular axis. मतलब x axis perpendicular to y y, और इन x x और y y दोनों एक्सिस को जो परपेंडिकुलर है उसके अबाउट अगर मोमेंट ऑफ इनर्शिया लिया तो वो क्या हो गया? पोलर मोमेंट ऑफ इनर्शिया. फॉर एग्जांपल, दिस इज x x axis and this is y y axis. Okay, x axis this, y y axis, and this is the axis z z axis. So this axis z z is perpendicular to both x x y y, and x x is perpendicular to y y. So about this axis what we'll get? I x x. About this axis what we'll get? I y y. And और इन दोनों को perpendicular कौन सा है? ये z axis. So about this axis we get I z z. इसीलिए उसको polar बोलते हैं. Okay. So we are finding here J is polar moment of inertia. So according to perpendicular axis theorem, how can we find this? Ixx plus Iyy. अभी Ixx मतलब कैसे find करेंगे? Ixx मतलब क्या है? It is the moment of inertia of this weld system about its CG. अभी ये weld system मतलब कितना weld है? सिस्टम में दो weld है, एक ये weld है और एक दूसरा weld है. इनका CG कहाँ पर है? यहाँ पर G. और उस G में से पास होने वाला एक्सिस कौन सा है? XX. It means that Ixx is equal to moment of inertia of this weld about this axis, XS axis, and moment of inertia of this weld 2 वाला about this axis G वाला. Okay. Now, how do we find this Ixx1? तो Ixx ये तो हो गया प्लस Ixx2 plus h square. This will give us Ixx. Now how to find first Ixx1? Ixx1 कैसे फाइंड करते हैं? 1/12 BD क्यूब और DB क्यूब, एक फॉर्मूला है हमारे पास. ठीक है, तो पहले हम फाइंड करेंगे Ixx1. Ixx1 मतलब क्या है? मोमेंट ऑफ इनर्शिया ऑफ दिस वेल्ड. ओके, दिस वेल्ड नंबर 1 अबाउट इट्स ओन CG, उसके खुद के CG के अराउंड. तो उसके लिए हम फॉर्मूला क्या यूज करते हैं? 1/12 BD क्यूब. Now if you remember, I told you when I explained the design of quarter joint कि क्यूब किसका रहता है? परपेंडिकुलर डायमेंशन का. अभी परपेंडिकुलर डायमेंशन कौन सा है? ये कितना है? S, that is size of weld. Correct. So what will this be now? So this will be equal to 1/12 परपेंडिकुलर मतलब S, और ये दूसरा डायमेंशन कौन सा है? 50 into S cube. This is Ixx1. Okay. Similarly, what will be Ixx2? This will also be equal to 1/12 BD cube or DB cube, whatever you write. Again, this dimension is 50 and this dimension is S. So simply what I can do, I can simply find the moment of inertia of the first weld and multiply it by 2 because it is similar. Now what is left to find? AH square. AH square. A क्या है? A is the area. That is T into L is A into H is what? H is the distance between CG of this weld and CG of the weld system. See, what is H? H is distance between this दो वेल्ड के CG के बीच में का distance is H. Okay, so what is H here? If you refer the figure, we come to know that H is what? H is 4040. H is 4040. We are considering this weld as a line. So ये जो पूरा वेल्ड है, इस वेल्ड को हमने S कंसिडर किया. So you can consider it as a line. So H can be considered as 40.
सर 40 plus S/2 होगा ना?
No, we can ignore that because we are considering this weld as a line. Because this distance S is small. Okay, it is a small distance.
Okay, sir.
That's okay. That's why we are considering it as a line. What you are saying is exact. It's correct that it will be 40 minus S by 2. Okay, but then we are ignoring this distance. ये इतना जो दिखा है, इतना बड़ा रेक्टेंगल जो ड्रॉ किया है, इसका 50 करेक्ट है. ये S is almost negligible, and we are considering this as a line. Okay, that's why we are not considering S by 2, so we are considering it as 40. So A into H square, and H is what? 40 square, is equal to T is what? 0.707 into S into L is 50 into 40 square. So this will be okay. अभी देखो हमको फाइंड क्या करना था, हमको फाइंड करना था J. J कैसे फाइंड करेंगे? I x x प्लस I y y. अभी तो हमने I x x भी पूरा फाइंड नहीं किया. अभी I x x क्या आएगा फाइनली? I x x is equal to 2 times 2 क्योंकि दो वेल्ड है. 2 times what? I x x 1 plus h square is equal to 2 times I x x 1 हमने क्या फाइंड किया यहाँ पर?
S
4.17 s cube. So it is 4.17 s cube plus what is h square? H square is this 56560 s. This is ixx. Now how do we find iyy? Again similar to that. So I will write 2. Now do we have okay, what is this? This is which theorem? This one.
The parallel axis theorem.
Yes, this is parallel axis theorem. Do we need to use this parallel axis theorem for iyy?
No, sir.
Okay, we do not have to use. So what will we write? We will simply write I. We will simply write this is 1 by 12 into what? dB cube. So perpendicular is what now? Perpendicular is 50. So S into 50 cube. So this will give us the value of iyy. Okay, what we did here, we found the value of J. What is J? J is moment of inertia of the weld system about x-axis axis plus moment of inertia of weld system about y-y axis. Okay, so it can be done. How it can be done? Ixx of this plus Iyy of this, that will give me J1 plus Ixx of this plus Iyy of this, that will give me J2, and J1 plus J2 will be equal to J. This is one way of doing. I am repeating. I want the value of J. Okay, J. See now, I am telling you something easier way, a trick in this. What I want? J. Now J, I am saying J is equal to J1 plus J2. What is J1? J1 is for first weld and J2 is for second weld. Since we have two weld here, this is 1 and this is 2. So J1 plus J2. Oh, no, J1 and J2 both are equal. So what I can say? J is equal to 2 times of J1 is equal to 2 times of J2. Are you getting this? J is polar moment of inertia, that is equal to polar moment of inertia of first weld and addition of polar moment of inertia of both the weld, first and second, that will give us the J. J is what? Polar moment of inertia of the entire weld system. Now, how do we find J? J can be found by J1 plus J2. So instead of J1 plus J2, I will say it is 2 times of J1 or I will say it is 2 times of J2 because इस वेल्ड का और इस वेल्ड का पोलर मोमेंट ऑफ इनर्शिया सेम आने वाला है. So I say it as J. Okay, now the question is how to find J1 or J2. The procedure to find J1 and procedure to find J2 is same, so that's why we have multiplied it by 2 here. Okay. Now how do we find J? J is what? Ixx. So in this case 1 plus Ixx 1 plus Iyy 1. Now how do we find Ixx1? It is 1 by 12 dB cube or BD cube plus AH square. And how do we find Iyy1? 1 by 12. If it is dB, then it will be BD cube. See, this is the red color explains the entire theory. So we start with finding Iyy, then Ixx, and then J, and this. So let me say it as J1, and then this is J finally. So how do we find Iyy? Iy we found by using this formula 1 by 12 s into 50 square cube. Ixx is this thing. Ixx is Ixx1 plus a square. Now in this you can reduce the calculation a little bit. How you can reduce the calculation? Same thing I am going to explain you again, and in a shorter way. You can do it in a shorter way. How? This is one weld. This is second weld. Okay, we know the distances. Let this be T. Let this be L. This is T. This is L. We know there is somewhere G here. G. So I will say this is Ixx. This is Ixx. This is CG of this weld system. So this is Ixx1, Ixx1, and this will be Ixx2, Ixx2. No, I told you what we have to find. We have to find Ixx. What I will do is Ixx1 is equal to 1 by 12 perpendicular cube. Perpendicular cube मतलब किसका cube? T cube into 50. Okay. Now this is equal to 0. This we can take as 0. Okay, because see, if I take it 0, this calculation gets reduced. This calculation, this thing what you have done, this thing what you have done, this gets reduced. Now why 0? Understand why 0? You will get the same answer. You will get the same answer 10.8 whatever you got. So this will reduce the calculation. Now since T is small and less than 1, so T cube will be much smaller, and since it is much smaller, so we can ignore this quantity and we will take it as 0. So that's why Ixx1 is 0. Now what is Ixx? Ixx is equal to
AH square.
Ixx1 plus h square, out of which this is 0. So this is what? Ah square only. This is a square only. And what is that a square? 56560, correct? 56560 s. So what is Ixx now? Ixx is equal to 56560 s. Okay. Now what is Iyy? 1 by 12 into Iyy is same as usual, and there is no change in that. Iyy is 1 by 12 s into 50 cube. S into 50 cube. So that is equal to 20833.3 S. So what has happened here? This term is eliminated. This term is eliminated. We are making it 0. So next time when you will solve this sum, you will not do this calculation. You will straight away write Ixx1 is equal to 0 as T is equal to small. That's it. Sufficient.
सर और हम लोग ने इसमें थीटा भी कैलकुलेट नहीं किया था ना?
थीटा तो कैलकुलेट करना है ना बेटा, विदाउट थीटा कैसे मिलेगा तुमको? हाँ, थीटा कैलकुलेट करना है. ठीक है, अभी आई एम गिविंग यू वन मोर सम टू सॉल्व. Okay, and you are not going to solve it now. You just understand how to solve it. Similar sum. Suppose this is 200 kilonewton. Then there is a weld here. Okay, similar to abhi jaise tha वैसे. There is another weld here. And in addition to this, now where is the CG of this line? The CG of this will lie here. All of you understand this now? CG will lie here, correct? If this is say 50, CG will lie at what distance? 25. All of you understand this. But the moment I say that इसको मैं इधर से भी weld करता हूँ, I am welding it from here also. Okay, so your vertical CG will not change because this is added here. Vertical CG will not change, but horizontal CG will shift from this point to this towards this. CG shift हो जाएगा इधर, correct?
Yes, sir.
Now, what you have to do in this sum? You have to find the CG. You have to find the CG of this weld system. So if this is, say, forgive me for this, lines are not coming straight, 100. Okay. And eccentricity is not known to us, but what is known to us, that this distance is 120. Why eccentricity is not known? Because we don't know the CG. ये तो 50 already मैंने दिया है, so this is repeated dimension. Now this sum all of you will solve, okay? But understand what you have to do here. The first step is to find CG, okay? First step is to find CG. So how will you find CG? X bar and Y bar. You know how to find F bar? A1 X1 plus A2 X2, A1 plus A2 plus A3. All of you know this. How to do? Now, since you are considering this as a line weld, so A1 मतलब कौन सा 3 वेल्ड है, तो मैं यहाँ पे 3 वेल्ड दिखाता हूँ. This is 1, this one is 2. I'm not going to solve the entire sum. You have to do it. I'm just telling you how to solve. So A1 is T into 50.
Sir, the center of the first weld, 25.
25, correct. And where are we going to find it from? We are going to find it from here. So from this point, we will get the CG. So this will be how much? Into 25. Plus A2 is what? 100 into T into what will be the distance? X2 will be 0, correct? Plus A3 is again same, T into 50 into 25. Okay, so this will give us the value equal to 12.5 mm. Is G. At what distance? 12.5 mm. Okay, this point is G. Have you understood this?
Yes, sir.
So what is eccentricity now? Eccentricity is यहाँ से लेके यहाँ तक. That is 120 plus
minus X.
50 minus 12.5. Correct? This will be the value of E. Now, I want to explain you how to find the value of J. In fact, J. Now this can be done quickly, since you know this, already know this. ये पहला वेल्ड है, ये दूसरा वेल्ड है, ये तीसरा वेल्ड है. इसका CG कहाँ पर है? Here. Where is the CG of this? Here. Where is the CG of this? Here. And where is the CG of this rivet system? The CG of this rivet system is यहाँ से 12.5 पे, मतलब ये point. This is G. Okay, so this is say XX, this is XX1, XX1, this XX2, XX2, and let this be XX3. Now XX3 coincides with XX. Now how will you find the moment of inertia? तो पहले हमको क्या फाइंड करना पड़ेगा? J1 फाइंड करेंगे, फिर J2 फाइंड करेंगे, फिर J3 फाइंड करेंगे, and then we'll add J is equal to J1 plus J2 plus J3. That will give us the total value of J. अभी J1 कैसे फाइंड करते हैं? J1 is equal to IXX1 plus I y y 1 J1 किसके लिए पहले इसके लिए ये सेक्शन 1 है 1 this is 2 and this is 3 now since 1 and 2 are same so I can write directly 1 और 2 के लिए same आएगा so I will do it for 1 and multiply it by so it will be 1 by 12 now I am finding ixx1 ixx1 will be 1 by 12 into this distance is how much this is 50 and this is t into t cube so t cube means what is this this is 0 plus h square plus iy is 1 by 12 into t into 50 cube. Have you understood this?
Yes, sir.
Okay, J2 is also equal to J1, so you can multiply. And what is J3 now? J3 is for this vertical weld. So for vertical weld, I can write again 1 by 12 into, see, vertical distance is how much? 100 into horizontal distance is t cube plus 1 by 12 into t into 100 cube. This is this is ixx, and this is iyy. So you can take this as equal to 0 plus 1 by 12 t into 100 cube. That's it. That is J3. So this can be taken as 0. So you can see this can be taken as 0 and there is no AH square in this. There is no parallel axis theorem used in this. Okay. There is no parallel axis theorem used in this. Why?
Sir, because xx3 coincides with xx.
Yes, there is no vertical distance between xx3 and xx. एक ही line पे है, no vertical distance. So there is no need of any what we say parallel axis theorem.
और सर मैंने cos थीटा इक्वल टू 50 माइनस एक्स अपॉन R2 लिया था सर, राइट है ना?
पिछले सम में
हाँ सर, मतलब उसमें तो सेंटर 25 था ना सर, तो 25 अपॉन R2 लिया था cos थीटा.
let me check. Cos theta is which is cos theta here? See, which is cos theta?
सर बेस अपॉन हाइपोटेन्यूज.
Understand? This is tau 2. Okay, and tau 1 is vertical, correct? So this is cos theta because this is tau 2. Both are parallel. So this is theta. This is theta. Now this line is perpendicular to this line and this vertical line is perpendicular to horizontal line. So angle between this line and this line is also equal to theta. So this is theta. And now what you want? Cos of this. So you know opposite is 25 and hypotenuse R2 is already found. So you can get the value of cos theta. Clear?
Yes sir, तो सेम लिया था.
Okay, no issue. So I think this is the most critical part in this welded joint. एक और सम बाकी है वो मैं next lecture में लूँगा. उसमें भी थोड़ा explain करना है and I hope all of you will solve this. Okay, this is not given as a actually this is solved I think all of you